Hi everybody. Today my topics is decision making models under risk. Let's move ahead in next slide to see in details of it. Decision making, it has three options: under certainty, second one is under risk, third one is under uncertainty. Today our discussion will be on under risk. So decision making under risk models assume that we do not know the outcomes for a particular decision, but we do know the probability of occurrence of those outcomes. It's very important points. So decision making under risk when the decision maker has some idea about the probabilities of outcomes, and then we can use probabilities of outcome to find the best alternatives, and those are expected monetary values, expected opportunity loss, expected value of perfect informations. So in details we'll see in next slides. Here I have taken an example. For an example, it's like here there is three, alternatives. Because this Steeps Mountain Bicycle Shop, it is considering three options for its facility next year. So he can expand it, he can move to a larger facilities, he can make no change according to the market conditions. With a good market, with an average market, with a poor market. And payoffs are here like 76,000, 90,000, 40,000. So using these all payoffs and with these alternatives, we'll make a table. It's called Payoff Tables. So this is that table. Here there is alternatives: expand, move, and no change. And it is in these three rows. We can see it here. It is called also decision alternatives. That's why decision maker can choose one of the options from these alternatives. And in this column, we have market condition. It's like good, average, and poor. But decision maker has no control over this market situation. That's why we call this as states of nature or outcomes. And these values in this table are called payoffs. And we will use this table in next slides. And here I have mentioned some additional information which we need it especially the probabilities of good, average and poor markets, which are 0.25, 0.45 and 0.3. To find what is the maximum EMV, what is the minimum EOL, and I have to compute the EVPI, expected value of perfect information. So, expected monetary value for each alternative formula is this: probability into payoff. And EMV, it is the weighted average of all possible payoffs, where weights are probabilities of outcomes. So using this formula or equations, we would like to maximize expected monetary value, and we will select the alternative with largest EMV. Let's move in next slides. Here, with the payoff tables, additional things are this I added: expected monetary values. Now I'll show you how I got these values. So I will start from the first row, expand. Using this equation, probability and payoff. So probability, this row, and expand payoff is this. So we'll multiply 0.25 by 76,000, 0.45 by 30,000, 0.3 by minus 17,000. We can see it here. And we got 27,400. That's the value here. For the second options, for move, we will do the same procedure. These probabilities multiplied by this second row, move all payoffs, 90,000, 41,000 and 28,000. So we multiplied this by the probabilities respectively, and we got 32,550. That's the value here. For the third one, for no change, 0.25 multiplied by this, then 0.45 multiplied by this one, 15,000, then 4,000 multiplied 0.3, we get 15,550. So it is here. So we got EMV, this. Three values we got. Now, we have to select the maximum one, largest one, that is 32,550. That's why I wrote here move facility options. That's what it is showing. So we got EMV as 32,550 because we will use this value in the next slide. Now EOL, expected opportunity loss for each alternative. It is the difference between optimal payoff and the actual payoff. And we are using formula as probability multiplied by regret, and EOL is the weighted average of all regrets. It is most important points. Now we would like to minimize EOL. As well, we will select the alternative with smallest EOL. So let's move next slide to see how to do that. So decision table or payoff table, I am bringing it again here. So from this table, because there is a probability value is here, 0.25, 0.45, 0.3. So I will use this table to generate this table. How to? Because regret equal to best minus actual. So using this equation, I have to find all these regret values. How? Best minus actual. So for this column, if you look at, best is 90. So from this 90, I have to subtract these three values like this: 90 minus 76, 90 minus 90, 90 minus 40. So these are the regrets I got. Here there is no regrets. Same procedure I followed for the second column in average. 41 is the best. Subtract 30,000, 40,000, 41,000, 15,000. So we got these regrets. Here there is no regrets. For the poor, this is the best 4,000. So 4,000 minus these three values. So I got 21,000, 32,000 and 0, no regrets. So all this regret, this value, I will put in another table in the next slide. These are the tables. All these value are the regrets from the previous table, and this is the probability. Now our task is to find this EOL, expected opportunity loss. So these three value, how we will generate? Let's see one by one. First I will show in expand row. So this is the formula: 0.25 multiplied by this 14,000, 0.45 multiplied by this 11,000, 0.3 multiplied by 21,000. So we get 14,750 here. This is the value of EOL. This is for the expand. Now we will find for the move. So EOL for the move, here I have written move. It will be like this. This is 0, this is 0, this is 32,000. So it comes 9,600. So this is the value. Now for the third option, no change. Using same formula, 0.25 into 50,000, 0.45 26,000, 0.30. So we are getting 24,200. So this is the value. So these three are the EOL. But we have to select the smallest one. As I have said in previous slide, we have to select the smallest one. So this one. 9,600. So I select this one. So move facility options we have chosen. So in the previous slide, in expected monetary value, we have chosen alternatives with maximum value, maximum EMV, but this one we are choosing alternative with minimum EOL. But previous one also was move. Now for this one EL also we are choosing the move. So the alternative suggested by that maximum EMV is the same as alternative suggested by minimum EOL. This is very important points. Both cases we have chosen the same alternatives. Now here we have perfect informations. If we have perfect information, then we can never have any regrets. It's very important points. If we have perfect information, then we can never have any regrets. So we found in previous slide minimum EOL was 9,600. That was the minimum EOL. So the expected value of perfect information is equal to the minimum EOL. This is very important points. Expected value of perfect information is equal to minimum EOL. In the next slide, we shall prove that. Here we can calculate expected value of perfect information, but we need to find expected value with perfect information. First we have to find this expected value with perfect information. So we will use weighted average payoff with certainty. We will use these equations, this formula, probability multiplied by best payoff. This point is very important, best payoff. We have to choose the best payoff, and then we will multiply it with the probability, then we will get expected value with perfect information. This is the equation. So let's see here. And expected value with perfect information, normally it is the average payoff when we have the perfect informations. And as we have seen in the previous slide, maximum EMV or minimum EOL, we can do it without any information, but here this one expected value with perfect information, we can find it with this formula, probability and best payoff. And how to get the best payoff? Let's see a table. So best payoff For this line column, you see this is 90,000 best payoff. For this column it is 41,000, that's why I have chosen that. For best payoff 4,000, I have chosen that. That was the definition, it is written there. So we followed that and it multiplied by all the probabilities. Then we got this value 42,150. Now we have to find EVPI. So EVPI, this formula is EVWPI, this one, minus EMV, expected monetary value. Here it is shown, it was maximum value we have taken before, that is 32,550, so it is here. And this value, it is from here. So we got how much? 9,600. So this 9,600 in the previous slide, we have seen this was the minimum value for EOL. Let's see that slide. I want to bring that slide again. This is the slide. This is the table we had in previous slide. You see EOL. We choose this one, move 9,600. This is the minimum EOL. So this is 9,600. So EVPI equal to minimum EOL. This is very important point. EVPI equal to minimum EOL. For today. Thanks for watching.